Hello students, I'm Satyendra. I'm going to teach you about the Rutherford atomic model. So, what is Rutherford atomic model? Rutherford performed an experiment known as alpha scattering experiment to verify the J.J. Thomson model, and after that he come to the conclusion that how the arrangement of proton and electrons should be inside the atom, and that model is called Rutherford atomic model. So let me explain you what was the experiment. The alpha scattering experiment consists of three major components. Okay, the first one is alpha particle emitter, the second one is gold foil, and the last one is fluorescent screen. You can see that this fluorescent screen. So my first question would be, what is alpha particle? You may be familiar with the helium atom. Helium atom has a 2 proton, and that is atomic number is 2 and mass number is 4, number of neutron is 2. If we remove 2 electrons from the outermost shell of helium, so it will become helium plus 2. Helium will be ionized and it will become helium plus 2. So helium plus 2 is basically alpha charge particle, right? So alpha charge particle is helium plus 2 ion, right? And what is gold foil? Gold foil, and why we are choosing that gold foil? See, Rutherford wanted the foil to be super thin, and we know that the gold is the most malleable element. That is why he chose the gold foil. Yeah, even if you compare it with aluminium foil, it is more thinner than that. After that, what is this fluorescent screen? This is made up of zinc sulfide. And what is the property of this fluorescent screen? That if any charge particle after passing through the gold foil strikes this fluorescent screen, then this fluorescent screen will glow, and in order to observe this screen, the room should be dark, right? So this is it. Now let us understand each component in detail. Let me erase this. Okay, so the first one is alpha particle emitter, and the alpha particle emitter, the source is there inside the lead box. This is basically a lead box. There's a small opening outside of this lead box, from which alpha particle are passing through a straight line, because there is only a small hole from which if alpha particle will pass, then it will pass through a straight line. And after alpha particle strikes on the gold foil, okay, then we can see that there are several paths of the alpha particle. Okay, and wherever the alpha particle strikes on the fluorescent screen, we can see the glow or sparkle. So this was the experiment. So let me put forward you the observations which was concluded after doing this experiment by the Rutherford. The first observation was that nearly more than 90% of the rays passes through this gold foil undeflected. Means there were no change in their path. Some of the rays shows minor deflection, and very few rays, means nearly 1 out of 12,000 rays, were rebounded back to their original position. So this totally surprised Rutherford. How could this happen? Because if Thomson model would have been right, so the result wouldn't have been like this. So let me explain you that if Thomson model would have been right, what could have been the result? So this is the Thomson model. Okay, let me zoom this picture. Yeah, so this is Thomson model. Yeah, so Thomson stated that Thomson compared the model of atom to that of watermelon. You may have seen the watermelon. In that edible parts, that is the red part, he compared to that of proton, while the seeds he compared to that of electron, and edible parts is distributed whole throughout the atom, and the number of positive charge equals to number of negative charge. So let us do that experiment and suppose that if the model is like the Thomson model, what would happen? Yeah, so suppose if I'm passing this rays, alpha rays, okay, alpha rays, and electrons is distributed whole throughout the atom like this, like in the form of the seeds, and proton is this positive charge. So alpha particle is basically helium plus 2 ion. Okay, so there is 2 positive charge inside the alpha particle. Okay, got it. And if we see about the electron, compare the proton charge there is a +1 charge on proton. Okay, and if helium +2 charge is passing through the sphere in which there is a proton distributed whole throughout the sphere, so isn't it that there will be some deflection? Isn't it that there will be some repulsion? And isn't it that the path of the alpha particle will show minor deflection? At least minor deflection would be shown now. So there would be some deflection, right? So this contradict the first observation. The first observation where that was that more than 90% of the rays were past the gold foil without any deflection. But how can this be possible? And the most surprising part was that some of the rays, very few rays, were rebounded back to its original position. Oh my god, how this can happen? Miss, 90% of the rays pass undeflected and only few rays were there which was rebounded back to the original position. So to make you understand little better, let me put forward an analogy in front of you. Just wait, and it would be very interesting to see this. You may be able to relate it better. Okay, wait for a minute. Let me zoom this photo for you. Okay, so here it is. This is the barbed fence wire, and I said to you that stand here and throw 1000 balls. You have to throw 1000 tiny balls. Okay, just let me know, if you are throwing 1000 tiny balls, what is the probability that the ball will go to the other side? Yes, you are right. Most of the time the ball will cross the fence and will go to the other side. Miss, if you are throwing the ball 1000 times, maximum number of times it is going to cross the barbed fence. Why it is like that? Because you can see that there is a large number of empty spaces. Okay, acha. Only sometimes it would happen that if you throw the ball, it will pass nearby region to that wire and there will be some minor deflection. And very few times it will happen that if you throw the ball, it will directly hit this wire and it will return. If you throw the ball, it will directly hit this wire and it will rebound to its original position. Get it? Now let's compare this analogy with that of Rutherford model. You can see this empty spaces. So that empty spaces can be compared to the free spaces inside the atom. Miss, you can clearly see that more than 90% of the spaces in the atom is going to be free. There would be no any charge particle present. So this is Rutherford model. You can see that this is the electron and this is positive charge atom, positive charge nucleus in which only proton is present. I would come to it later. So you can see this large number of empty spaces, right? So when the rays will pass through this empty spaces, there would be no deflection. Okay, now the last observation that only few rays, 1 out of 12,000 rays was deflected back to the original position, was rebounded back to the original position. So see that the proton, the positive charge particle, is inside the nucleus and it occupies very little space. Means if I compare the nucleus size to that of atom size, so nucleus size is 10 to the power minus 15 while the atom size is 10 to the power minus 10. So nucleus occupies 10 to the power 5 times less space as compared to that of atom. So this was final observation of Rutherford and he put forward his model as Rutherford atomic model. So what, let me draw this model once more for you so that you can understand better. So by this experiment it was clear that the proton is going to occupy a very less space, yeah, and it is in the center while the electrons are revolving around the center and there are free spaces around the atom. But if Rutherford model was totally true, then there was some minor contradiction. Yeah, and what was that contradiction? That contradiction was that if there is a positive charge atom, positive charge proton inside the nucleus, and if the electrons is revolving around the nucleus, and just let me know, if electrons are revolving around the circular path and it is accelerating, then isn't it that electrons will radiate some energy? and if something is radiating its energy, then slowly its energy will decrease, and the path which electrons was taking will become a spiral, and after some time it will merge in the proton. Isn't it like that? So how can the atom be stable? We certainly know that atom is stable, but this model cannot explain the orbits in which the electrons are revolving, because according to the theory, if at certain orbits electrons are revolving, so it will radiate energy, and this couldn't explain the stability of the atom. So this contradiction was explained by the Bohr theory. And what was the explanation? The explanation was that there is a positive charge proton, okay, which is kept inside the nucleus, and there is only a fixed orbit in which the electrons keep revolving around the nucleus, and that is called discrete orbit. And whenever the electrons revolve around that particular orbit, that particular path, there is no any radiation, there is no any change in the energy, there is no any release in the energy. And if the energy will not change in that particular orbit, so the path will not change, and the electrons will keep revolving around that particular circular path, which is called discrete orbit. And that orbit is called cell. You may be familiar with the cell. The first cell is called K, second cell is called L, third cell is called M, and so on. So this is it. This is about the Rutherford atomic model. This is all about today. Thank you.